Hello everyone. In this demo, I'm going to show how self-hosted SD work and the benefits of using it. Let's get started. First, we are listing the instance we have on GCE. We are using this for instance for our demo. And now we are SSH into one of the machine. We are logged into the machine so that we can use the kubectl to see the parts. And now the API server is not running yet, so we see connection was refused. And now we are trying to create the master components, including API server, in the node we just SSH into. So now we go back. We are displaying all the parts in the kubesystem namespace. Now the API server is up and running. And now we are waiting to see the Bootstrap SSD part showing up. The Bootstrap SSD part is used by the boot queue as a temporary data store. It's eventually going to be replaced and migrated onto a managed self-hosted SD cluster on Kubernetes. Now the SD operator is still creating. We are waiting for it to be running. So after it's running, we are going to create a SD cluster TPR. The TPR is going to be used by SD operator, and SD operator will create a managed SD cluster on top Kubernetes. Let's wait a bit. We should see the cluster TPR is created, and we will see shortly. So there's a managed SD part created. This part is formed as a core with the Bootstrap SSD. We'll see shortly its members. So here we are trying to get the service. We will see a service which is SSD service. This service is pointing to the managed SSD part. So now we're trying to get the members from the SD server, and we see the current membership. So the current membership consists of both the Bootstrap SSD and the managed SSD part. And then we remove the Bootstrap SSD from the membership, and that caused the control plane to be done temporarily. And after a while, the self-hosted control plane is going to take place. And the self-hosted control plane is relying on the self-hosted SSD we show here. And as we see here, even though the control plane is done, we can still talk to the service. Does talk to the managed SSD part. So this SSD part is managed by SSD operator, and SSD operator does such as resizing, upgrading, and backup automatically. And in the outside, we can use the pre-generated kubeconfig to talk to the API server. So we can. One benefit of self-hosted SSD is like we can inspect the configuration of the SSD and etc. easily via kubectl. So we can label it. We know its image, its version, its volumes, its IP, all those things via kubectl. Like we and where what is the node it's running. And we can also get the logs in kubectl. That's just so convenient. And we can inspect the cluster spec. So the spec, it's the desired status of the SD cluster. So the current size is 1 because we only have 1 node, as we see here. But as we showed before, listen instance show that we have 4 instances. So we are gonna add the WES3 instance as nodes into the cluster, Kubernetes cluster, one by one. And we should be able to watch the nodes being added like eventually and gradually. So we have other nodes being added. They are registered with the API. Now we have all the 4 nodes being added into the Kubernetes cluster. And now let's watch in the SSD parts. Now we just have only 1 part, but we are going to resize it to 3 right now. But first of all, the control plane can only run on master nodes. We need to label other nodes to be master as well. So we label the nodes one by one. And we see that the other nodes are being labeled as master nodes as well. Now we are gonna change the spec to be size of 3 due to a bug in the Kubernetes less than version 1.6. Like we can only do kube apply in such a way, but in Kubernetes 1.6 and later releases, this bug has been fixed and we can use kube apply again. So this is basically doing the same way as kube apply, but more hackish. And now we have kube apply. We will just watch the other 2 parts being added shortly. as we watching the pods being added, we can also see its membership being changed as well. Now we see the membership contains all 3 pods. So we see that's pod 01, pod 00, and pod 02. Exactly what we saw in the left. Now we are going to do another task, which is going to upgrade the SSD cluster version. So we see the current version is 3.10 because the spec says we want 3.10 version. And we see the exact same thing in the pod in the SSD pods. Their YAML files show that their pod spec show that they're running the 3.10 image the version image. Now we are gonna do the hack cube apply to change the spec version to be 3.13. So instead of upgrading SD pod image one by one, we just say, oh, we want the SD version to be 3.13, and SD operator will do this for you. It's gonna upgrade all the parts in the cluster to be 3.13 version. So we see the parts image is gonna be updated one by one, and eventually all 3 parts will using the 3.13 version image. Now let's look at the cluster TPR again. The status show that the current version cluster version becomes 3.13. So currently we have all 3 SSD pods running on 3 different nodes, 1.5, 1.4, and 1.6, and we are going to kill 1.6, which is core 3 nodes. That means the pod is going to be unresponsive, and we are going to show that we can use by using self-hosted SSD, we can rescue that SD member declaratively. So we should see that node it's gonna be not ready in the status. That means the node is unresponsive because we just killed it. Now if we see from the cluster TPR status, it's gonna say, oh, the pod running on that node, it's unhealthy. So we grab the pod's node name, we see it's running exactly on the node we just killed. So now we are going to delete the nodes, and the pod is going to be removed from the API as well. We see this is Kubernetes feature. So operator is gonna file, oh, we should have size of 3, but now we only have 2 members. It's gonna add another member into the cluster. It's gonna replace the free one and add a new one in existing nodes, which is the other node that we didn't have SD port before. There we go. So now we see the new part is being located on 1.7, where the old part is located on 1.6, and we kill the 1.6. So the new part is running on 1.7.